discussing. That is
Sure. I won't mind being part of the project. So
yeah. So that is like a e-commerce plus service-based app, and what we have developed for our client from in Nigeria. I think they are based out of Lagos, Chevron. So
did you say Chevron?
no, that the company is based out of Lagos, Chevron. I think that is their
Okay,
address.
Lagos. Okay,
Yeah,
okay, yeah. Okay, that's the address. Okay, yeah, Chevron. Okay, yeah.
the app name is Saluni, and it is already in live and is doing good businesses. And I think it is in the market for 1 month, and they have uh, ins they got like installed 7,000 in 1 month. So that is a good number. So we are
Yeah,
the one who
that's actually a good number.
yeah, and we are the one who developed and managing the infrastructure. Uh, but and we are right now working in 3 different projects also, the same Nigerian thing. But what the country is developing very fast, and every day what we are seeing, they are trying to move forward very good speed. So if you are in this tech market and you are having a cutting edge uh, field, it will be very great for you also. So how many years of experience do you have in DevOps?
Uh, 3 years, but yet I just have a very short uh, work experience in a live production environment.
Okay, now DevOps is a thing. It has 2 or 3 phases, right? Now it used to be called like a build and release engineer. Then it's evolved to DevOps. Now right now what we are seeing in the US job market, that thing happened is with a lots and lots of students who and consultant who are where we are doing the marketing for them. What we have seen that even they are applying pure DevOps position, but still the company or interviewer, they are looking some of the cybersecurity thing. That hey, did you ever uh, implemented? Now you have implemented CI/CD pipeline. Now, did you ever implement it? How have secured your pipeline? Uh,
But
what?
I think that's why I'm also interested in cybersecurity because basically you see a lot of DevOps role. They are majorly focused on security, which involves cybersecurity. So and both courses are kind of interwoven at some point, at some extent. So that's why cybersecurity is also an interest for me.
Yeah. Now we do have 2 consulting firm in US. One is Kalkey INC, another is SACSER. SACSER is software automation consulting firm. Now, as we are in the market, this has become a trend, uh, like 3-4 months, because before that, company normally for security, small company they used to hire a third party other company, right, or vendors to manage their security. Now to mitigate or slim down their uh, environment cost, it's better to having a DevSecOps engineer who have a DevOps idea as well as cybersecurity idea. So one person can, it will be a budget friendly for company, as well as one person, if they can find, this is a very key word. Uh, they can manage both of the thing single-handedly. But what we are seeing uh, in United States job market is most of the company they are struggling to hire this DevSecOps engineer. And frankly, in the market, it is very hard to find a DevSecOps engineer, right?
Yeah, it is. I think the major thing is in Africa and Asia, basically, they try to find one person that can do everything at once. They are not willing to employ different persons, one for DevOps, one for cybersecurity. They are looking for someone that can do both the job of a DevOps engineer and the job of a cybersecurity personnel. So that's why. But when you talk of Western countries, they do not have problems employing different persons, a DevOps engineer. You see in an organization in the US, you see the DevOps engineer is different, the cloud engineer is different, the cybersecurity person is different. So, but when it comes to, especially in Africa, they will rather look for one person that can do everything at once. So that's usually the issue.
No, I think that is the fundamental of everywhere. Even in the US, mm, uh, they are actually looking for one person who have experience in three different segments: DevOps, cloud, and cybersecurity.
The reason why I'm saying so is
Yeah.
I was in a project for a company in Texas some months back,
Hmm.
and I was a DevOps engineer, and my CCO was already talking about employing someone that was as a cloud engineer separate from me. And I wasn't going to tell him not to employ a cloud engineer because it was going to basically reduce my workload if he employed someone else separate from me to do cloud engineering, which so he was willing to employ.
Now there is a reason. Uh, if you consider 2 years before, while 2 years before, I think the Netflix is the first one who had the full live DevOps cycle on their production field 2 years before. But now 60% company either they have fully evolved their CI/CD pipeline on their SDLC lifecycle, or they are going to migrate fully. So now, while they are like last 2 years, they have only single goal to move to from monolithic to agile methodology. While they have moved, now they have a concern that how to first they need to manage their pipelines. Second, also need to secure their pipelines. So that's the reason we are seeing more and more DevSecOps engineer. And that what is the call? What is the position name? Um, so Devashish, we are discussing about that. There is one more position.
Is it SRE?
Sorry, yes, site reliability engineer. This position it will grow very fast. This is like another name of DevOps, but it is normally while your DevOps is in on the production cycle and you need to manage a live application, then only the company normally try to hire this SRE position people. So what we will see after maybe 1 or 2 years, this DevOps, SRE, and cyber DevSecOps will combine itself and create a single position again, because all are correlated, right? Okay, thank you, Jay. So yeah, I think I am not going to waste any of your time. So if you don't have any other question, I think Mr. Karthik, we can start. Or if you have any question, we can squeeze 5 minutes from that. Anyone? So one question I got that few days before we upload one job role, based out of Chicago. Now that job role is already we have submitted and it is closed. Keep an eye on that group. Now here is the thing, whatever job role we are going to post, if we have any extra position, the reason behind, we do have our own consultant and student who have done our job ready training. Most of our people, their first preference is remote position, because that is everyone wants that kind of position. But if we found some position where it is fully local and you have to go to on site, but unfortunately we don't have anyone on that particular location who wants to go on site position normally, so that the kind of extra position we do have, and we post in our groups. Now keep it in mind, if you are in the US and that particular location, then only it's matching with your profile. If you are outside of the US, to apply this kind of position, first you need a job work authorization, any kind of work authorization. If you have, then good, because most of these position, like 60% they don't want to sponsor. 40%, yes. Even if they cannot sponsor, we can sponsor, but it should come from the client as well. Okay, so there is a lots of legal compliances also involved for applying this kind of position. You can find that thing in USCIS website, or if you have any doubts or question, you can also ask us. Okay, I think yeah, you guys have no question for me. So yeah, Mr. Devashish, we can start for today's session.
Yeah. Sorry, I think my mic was on mute. I was wondering why no one is responding.
How's your day?
Yeah, day was good. It's a long travel today, so
yeah,
I just reached 5 minutes back, so I'm starting again.
Oh, you reached only 5 minutes before?
Yeah, like 10 minutes, so I had to freshen up and then sit here. No problem. Yeah, Bangalore traffic, as usual.
Yeah.
Fine. Can we have the recording started? It's not.
Yes, let me start. Yeah, start.
Yes. Today, guys, welcome guys for today's session, and this is going to be a very good session because this will be the first time we are looking at something from a security penetration perspective. So we talk about a lot about scanning and things, and what are the initial phases of scanning, the port scanning and those phases, and that is what we are going to talk about in this situation today. Before going to port scanning, so there is certain fundamental networking concepts that we need to be aware of, right? So we will look into that perspective as well today and see what are the things, and then we'll see how the port scanning is going to work out there. That is the criteria that we're looking at. So before wasting any time, let's start. Right, and this is going to be, since it's going to be hands-on, if you're getting stuck or anywhere in the middle, I request you to, unmute yourself and ask questions out there. That would be an ideal situation, So
now, guys, I have one more thing to ask. We always appreciate a conversation, because you guys are going to join our DevOps and cybersecurity position in today or tomorrow or day after tomorrow in the job market, and you need to talk with lots and lots of people, with industry expert, with your stakeholders and whatnot. So also do little practice while you have a chance. So we'll highly encourage, if you have any question. I know we don't like discourage this is a irrelevant question, this is a irrelevant question. You can chat or you can unmute and directly ask your question.
Yes,
it makes us also little bit confident that okay, everybody is understanding what we are delivering.
Yes, and today's session is also very important Because if you're someone who is a fresher and who want to get into cybersecurity, this will be a very important topic that a lot of interview questions are going to be based on. And Nmap, the tool that we are going to talk about today, is I think even I am conducting interview. I don't think so. I don't do any interview without Nmap, right? And for me to identify someone who is good with pen testing, especially at the infrastructure level, I like to see how good they are with Nmap. If someone can understand Nmap, I think we can train them to be very good pen testers or security analysts for the infrastructure part, right? So that is the process that we are going to see, right? So now, right, usually, so what is going to happen here is that whenever we saw in different phases of pen testing, one of the scanning phases is called as scanning. And to be more precise, it is going to be called as active information gathering. Right? It is not same as in reconnaissance, because in reconnaissance we are connecting, not interacting with the target. We are directly interacting with public available websites like LinkedIn, Instagram, looking at the user, what could be their knowledge, and what we are trying to guess what kind of infrastructure or the software process that any application, any company is running. But here we are not looking, we are looking very specific out here. We are actually pinging and seeing what are the things that could be running out there. Right? So let's assume something, right? Okay, so let's assume there is a web server. There is a web server, right? Let's say this is going to be xyz.com, right? So that is going to be, and let's assume it is going to have a public IP address 11.11.11.11, right? This is going to be there. And the services that are running inside this particular is Apache SSH is running, in some case maybe VS FTP also, right? So now what does the scanner do? On a base level, what does a scanner do is what we need to know, right? So scanner does is that is going to check what service is running, right? This is the second part, right? First part is that if the target is on or off, that is going to check. Then third part is going to be checking for the service information, right? Service information, it is going to check for that. So there are a lot of other things, but this is the base characteristics which I feel is important to understand. Anything more on this is going to be an addition itself and doing the same set of activities in a little bit different way. Right? So that is what is going to happen out there. So my question is, you should be thinking, how does an Nmap tool get this information? Right? Yes.
Just a minute,
Yes.
Mr. Karthik. Victor, can you turn off your camera, please? Victor Omokarbo, your camera is on. Victor, are you there?
Victor, your camera, turn it off. Victor.
I think he cannot hear. Okay, yeah, we can proceed, and I'll yeah, he turned off. Thank you, Victor.
Yeah. So now, so is it, how does Nmap is getting this information is the question here. For us to do this, get this, understand this behavior, Nmap is using predominantly two protocols here. One is TCP and one is ICMP protocol, right? TCP is the place where we are going to work on the reliability part. Okay, and ICMP is a protocol. We are going to look into that. Okay, so these two protocols are there for any communication with this device. And how does Nmap take these two applications, take these two protocol and manipulate this to get information is what is going to happen out there. Right. So now let's go back even bit further back than what I'm looking at here and see services and things that are there. I want to take you back to the bare minimum of networking, right? So that is what we are supposed to be looking at. So let's assume, right? Let's two devices are there. And this is not a client or a server or anything, right? It could be any devices, two devices. If they want to exchange information over network, there are certain bare minimum things that is required of them, right? And this bare minimum things is going to be, one is going to be MAC address. MAC address is important, but at the same time is not that important also, right? Second thing that is going to be is IP address. IP address is like your postal address. It will tell the any networking devices how to take one particular packet sent from one device and route it to the second device, right? It goes from one layer to another region because this could be in US and the other device could be in Japan. How does the packet know how to reach there? And IP address is what is going to be used out there. And till this usually comes in layer 2 and this comes in layer 3, right? And this is basically used by the middle level network devices, right? So I'm talking about your switch and routers. Going from one network to another network. It is the TCP part which is important, all right? So when we're talking about network layer, there is a standard. Every two systems will need to follow the standard for them to communicate, right? For instance, let's say if one person is speaking in English and another person is speaking in Japanese, they both will not be able to communicate. They have to negotiate a language that they both can understand and use that particular language as a mode of exchanging this. Similarly, in that particular way, there is something called as an OSI model or TCP/IP model that is going to be used out here, right? So this is what is going to be there. Every packet will have this information, right? Most of the time when you're doing this, we'll talk about OSI model. OSI model is a reference model only. It is not used in real time because it distributes the functionality of the packet in much more granular way. It is used for explaining situation, right? So for instance, at the network layer, your router is working. At the data link layer, your switch is working. If you see a network layer L2 engineer, it means they're looking at an engineer who has capability to configure and manage switches. And if you're seeing an L3 engineer, we are looking at someone who is working on a router level, some engineer who can configure router and manage routers and things like that. And predominantly, the firewall engineers will also come at the network layer only, right? Transport layer is also part of it, right? So these things comes at that part, but what about the other four layers, what we are seeing out here, right? So TCP/IP model will follow. We'll talk about transport layer and application. These two layers, what is happening out there? These two layers are going to be working on the device, right? When the packet reaches, this is where transport layer works and your application layer works. Application layer, the protocol like HTTP, right, SSH, all work on this layer. And we are not really worried about this particular path at the moment of them. We're talking about transport layer. Without transport layer, internet is not going to be possible, right? We cannot use internet in a reliable way, what we are going to use out there, because transport layer called as a, right? It is a reliability, transmission control protocol. The main protocol under this is going to be TCP. It's called as a mission control protocol, right? This is a reliable based. It is also called as connection oriented protocol and things like that. The main reason is that this is the only part of your network packet which tracks your packet. Meaning, let's say if I send a packet, a parcel to someone, right? When you book on Amazon, the Amazon will send that parcel to you. And once the user collects, there is the acknowledgement going back to the Amazon on that, telling that user received it. What if the packet get destroyed in the middle? The parcel is getting destroyed. What does Amazon do? It will repackage a new product and send it to the customer. It's similarly, when the packet is traveling over the network from one network to another network, there could be some reason the packet gets lost. Your network layer, data link layer, or application layer or anything are not worried about this. They don't care. If the packet is lost, it is lost. It is not worried about it. It is similar to your postcard, right? Postcard, whenever you visit any country or any new place, you take a postcard and send it back, right? There is no guarantee that it will reach. And that is why it is a cheaper option. It's not that expensive and things like that. But TCP is not like that, right? TCP is not like that. It is something it is going to control that process, right? And this is a very important concept to understand. How does the TCP is able to look at this factor, right? You take any communication, you are accessing a web server. There is something, what I'm going to talk about it now is going to happen between a web server and a client. Each and every, your Google server may be connecting to millions of desktops or laptops or mobiles or tablets. All of them will exchange this information in this particular, right? So how does the process works, right? So simple process is very simple. Whenever a packet is sent, let's say that I'm having 3 packets to be sent from the sender to the receiver, right? So now when I send the packet 1, after receiving the packet, the receiver will send a message that packet 1 is received, right? Only when this message I've received by the sender, it will send the packet 2, right? If I don't get the message back, it will wait for some time and it will resend the packet 1 till it gets an acknowledgement. And this is called as an acknowledgement, right? It's called in short form, it is called as an ISAK. Till the time I don't get acknowledgement for packet 1, I don't send the packet 2. After receiving acknowledgement for packet 1, I send the packet 2 to the receiver. Then again, I'll get an acknowledgement for what? Packet 2. Then only I'll send the final packet 3. Then finally, I'll get this operation. This is what is called as a connection oriented approach, because without getting a confirmation, I'm not going to send on to the next packet. I'm waiting for this process to occur, right? So this is how typically a communication takes place, but this is actually in the second phase, right? This is actually in the second phase, right? Now you understand this phase, telling that TCP is a protocol which makes sure before it receives a packet, after receiving a packet, it has to send an acknowledgement. Without receiving an acknowledgement, I'm not going to send for that, right? But what about this first packet you're sending? Where is the acknowledgement for that? Right. So randomly you're going to send like that, right? That is not going to happen. So for the first part, there needs to be a handshake. Right? There needs to be a handshake. What this basically handshake means is that these 2 devices that are there, they have to agree to communicate first. Right? Without agreeing for the communication, it will not send a single packet. Right? So how you usually do it on telephone call, right? You call up someone, You'll tell hi and they'll tell hi, then you exchange names and then you talk about the content that what is that you want to speak about it. In a similar situation here, what is going to happen is that here it is going to send something called as a sync packet, right? Sync packet basically talks about that I want to communicate. I want to communicate with you. That is what it is telling about that. And for that, the receiver B here is going to send something called as a SYN-ACK packet. So here the ACK packet is the acknowledgement for receiving the sync packet, and it is telling in the sync packet of the here is telling, but I am also ready to communicate. And finally, for this sync packet, I have to send back an acknowledgement. And this is called as a three-way handshake. Right? This is called as a three-way handshake. You take any communication between two devices. Without this, this is not going to occur. Right? This is going to happen out there. If as long as they're using TCP, transmission control protocol, it is going to happen. And this is what is common in all the for any website you'll be able to see. Let's try to see this in a practical way. Right? Let's try to run a small test and we'll capture the packets. Right? We'll capture the packets. For this, what we're going to use is just a minute. We're going to use two machines here. One is going to be my Kali Linux. Another is going to be my one more machine called as a B-box. So this is a please note scanning any devices on the network without their companies or the website permission is illegal by law, and you could be prosecuted for that. For that exact same reason, you should always download some vulnerable machines which can be used for practicing purposes. Please don't use, right? And whatever you're learning in this course, in this seminar, you should use it with your, you're responsible for your actions as well, right? You cannot use it for doing any wrong activity. So let me first delete the history. This is basically for making sure if there is any previous connection to the same website. Sometimes TCP handshake will not happen because it is already connected to that part. Okay, so it is 136. Let me come back here. Let me capture the Wireshark. Sorry, I am in the wrong one. Let me log out. I should log in as root user for this. I think I'm having a wrong machine. So now let's see 192.168. What is B-box IP address? 178.136. Okay. Before entering this URL, I'm going to start capturing packets in Wireshark. Let me do this and come back, press enter. The page is loaded. Let me stop this. Right? You could see there is a lot of packets between to and fro that is happening out there. So what is the IP address of my Kali Linux out here? You give ifconfig, right? It is 172.168.144. This is going to be the what? This is going to be the source address from where I'm starting the communication. The destination address is nothing but 192.168.178.136, right? This is my web server's IP address, right? Web server's IP address. And we have seen it here, right? The Linux machine I'm running here, this is a web server, right? So when you look at the Wireshark information here, initially, you can see here, SYN, SYNAC, and ACK. Only after that, the HTTP protocol is being sent, telling that I am requesting for this packet to be sent and received. Okay, every packet that is being sent will have this information. See here, if you come back here, TCP IP header, application, transport, internet, and link. 4 layers are here, right? So if you come back here, see here, this is your internet protocol, IP protocol. Every packet will have a source address and the destination address. You could see here. Then again, there's a transmission control protocol. This is where TCP is working, which is there. And finally, there is a hyper transport protocol. This is what is called as an application layer, right? That is how it is going to be taken care. And your other is this is your link layer information. The MAC address and everything will be stored at this particular layer 4. Right? So this is how it works, right? So I'm going to come back to this screenshot. Don't worry that I've closed it. I just showed SYN, SYNAC, and ACK. Karthik showed a little bit and then he's closing it off. Now we have to have a little bit more discussion on what is happening here, right? So what exactly is this, right? What exactly is this part? This is in this image, you can see is what a proper TCP information is going to be there. What happens for every packet you're going to send, there's going to be data. Along with that data, something is going to be added out here. What is added? There's going to be network information, right? Network data or control data. Also, you can take whatever you want. So now, as I told, TCP works at the device level. It is not something which is relevant at the network layer unless until it is a firewall which is making a decision, but it works at the system layer, right? So my question is, see here, in my web server here, I'm running multiple things. There is an SSH server service running. There is HTTP service running. There is HTTPS is running. Okay, FTP is running, and probably a mail server is also running, right? All these things are running out there. When a packet arrives, right? When a packet arrives at the server, how does the server CPU know which service I should give this packet to? Because everyone is communicating at the same time, right? Everyone is communicating at the same time. How does it give it to which person? Which packet has to be given to which service? Right? There should be some kind of a mapping, right? Because think about it, you got a mail to your house, but in your house there are 4 people out here. Whom does that 4 mail should go to? That information should be there. For to do that part, transport layer protocol has something called as a port number, right? Whenever a server runs a service, what is the whenever a server runs a service like in HTTP, it will assign a static port, meaning this port is not going to change. For HTTP, default port always is going to be 80. For HTTPS, it is always going to be 443. SSH, it is always going to be 22. FTP, I think it is 20 and 21. And there are 2 ports that are used. Mail depends on which, again, mail is a bit more complicated. depends on which we are using, it is going to port number is going to change. But any service which is working as a server, right, which is providing some kind of a service, will be assigned a port number. And this number, port number, is not going to be, what do you mean? Random. There are every system can assign a port number anywhere from 0 to 65,535. This is the maximum number of ports that are going to be there. So every system sending will have a port number. Every server website services will have a port number. That is for sure. That is going to be there. And this is very important. The static nature of this port number is what is going to be used by Nmap to know what services you could be running out. Okay. And that is how the process will look into that part later. So as you could see here, there are multiple informations that is being sent, right? It is talking about source port's IP address. A client will have a certain port number to be sent because we are not only looking at the server, your browser, right? Even your system is also running multiple things. You may be running browser, you may be running Teams, and different applications are running out there. When server responds back with a package, how does it know which machine it's supposed to go? Again, there will be multiple websites. One is Gmail, and other, let's say it's going to be Facebook or Instagram, something like that. When a packet arrives, how does it know which one I should give it to? There's so many things that are running. Again, the port number is going to be relevant in that case as well for both receiving and sending the packet out there. Correct. So that is one thing that is important. That is what is happening here in the part of the. So one more thing which is very important for us is the sequence number and acknowledgement number and the flags out here. We are not going to look at other things at this point, which is not relevant for us for today, but we are going to look at the sequence number and acknowledgement. So what is this sequence number, right? For instance, again, we'll come back to 3 packets, packet 1, packet 2, and packet 3. And we'll tell we're sending packet from USA and the packet is received in Japan, right? When I send the packet 1, this will take to a route. It will go to Brazil. From Brazil, it is going to UK. From UK, it is going to China. And China, it is going to Japan. 1 packet. And second packet, because there is no, this is happening at a microsecond, okay, or a millisecond, it is happening out there, even though it is able to travel from one continent to another continent at an extreme speed. So you will not know, right? So that is that. So for instance, the second packet may be going from all the way up to, let's say it will go to Brazil itself, but instead of UK, it will go to Germany. Right after Germany, it will go to South Africa. From South Africa, it will go to Singapore. From Singapore, it is going to Australia. From there, it goes to Japan, the final mission. And finally, here also it could be possible. It will directly go to Australia. From Australia, it will directly go to Japan. It may be a single hop out there. Even though it is a millisecond difference out here, right? Even though it is a millisecond out here, which is traveling thousands of kilometers, we think this is going to packet number 3 is going to arrive first. Packet number 1 is going to arrive second, and packet number is going to arrive third out there. For instance, hello, how are you? Right? Are you is in third packet. Hello is how is in second packet. Hello is in 1 packet. Right? If this order comes in, are you? Hello, how? Right? This is how the message is going to look like. And this is what is not something they like to have it out there. So they need to have some kind of a mechanism for understanding this process. So what they're going to do is that they're going to assign something called as a sequence number. Okay, so now whichever the way the packet will arrive whichever the order it is going to arrive. The Japan machine, which is in Japan, it will take the 3, 1, 2 and rearrange it to 1, 2 and 3 and then pass it on to the application that it is looking out for. And this is what the sequence number is basically about, right? Every packet is supposed to have this, and this is how we track whether the packet is missing or not also. Okay, so now let's understand what is a acknowledgement number. Right below that there was an acknowledgement number, right? So what is going to happen? First packet, I'm going to send hi, and there's going to be sequence number for the packet. Let's say the first packet is going to be 1111. The sequence number is going to be assigned that. So now the acknowledgement is very simple. It will not tell that I received. It will not tell I received 1111. It will not tell this. It will tell send 1112. This is the information. When I receive this 1111 successfully, only then only I can tell this packet should be sent next. Without receiving this packet successfully, I cannot tell send this packet out. Right? So acknowledgement is nothing but the second package number out there. There's another, slide window size. The acknowledgement may not be every time on the same page. That is totally fine. That is not part of this process out there. For every packet sent, the next packet is the acknowledgement out there. So now I will send the packet 1113. Sorry, 1112 because it is the acknowledgement number. Now with the acknowledgement is going to be 1113. Then I will go 1113. Right. So this is what is going to happen here. So now sometimes if I don't receive this number, right? If I don't receive in the acknowledgement message, that is how I know I have to resend the packet, 1111 out, right? Whichever the packet, let's say communication is going to happen, I have sent 111, 1112, 1113. Then again, I did not get any message. If I tell, then I have to know I have to resend the packet 114. This is what is going to happen out there using the acknowledgement out there. So typically your TCP three-way handshake, right? What it is going to be there. The sequence number and acknowledgement number is going to happen but 4 devices. Let's say for the A, the sequence number is going to start at 1000, and for the device B, the sequence number is going to start at 2000. It is going to be very long number. For here, for the sake of understanding this, we are going to do this packet, right? So now it was first send the sync packet telling that I want to communicate my sequence number is 1000, right? Sync packet. So the reply, what is going to be? There's going to be ACK part and there's going to be sync part, right? So it is telling, the B is telling I'm ready to communicate. My sequence number is 2000. Since I've reduced 1000, please send me 1001 packet. Okay, for that part. And now finally the ACK packet is going to be there. This is going to be reply for that ACK 2001. Right. After these three things exchange, the sequence number is going to keep on incrementing one by one. And that is how this is going to work. And this is three-way handshake is very important for me to know how the device is performing out there, right? For Nmap, you take any scanner of your choice, Nessus, Quali, or anything, you have your own custom scanner or anything. It is a three-way handshake that is used by, right, by the scanner to check whether a device, what services that devices are running out there. Okay, so that is how it is going to be there. Let's look at the practical way of it. So if you remember, we have already captured the packet, right, in the Kali Linux. Look into that. I'm extremely sorry that I am not able to zoom here, right? But we'll see. See here, we saw three-way handshake here. you can see as SYN in bracket, SYNAC and again an ACK is there in the packet. If you go to the first one out there, this is going to be in TCP protocol, right? So click here and you could see the sequence number is set. Where's the sequence number? Sequence number is 4033920,484 is the sequence number. Since this is the first packet, there is no acknowledgement being sent. Since this is the first packet, no acknowledgement is sent out there. And see here, take down this number, 40. Let's remember the last 3 digits 484. Now this is going from Kali Linux to the web server. Now you could see the second packet is actually reply from the web server. That is why it is telling source is 136, destination is 144. And here you could see the sequence number is changed because the web server has a different sequence number. But now acknowledgement, you can see it is not empty and there's an acknowledgement number. Previously it was 484, right? The sequence number, the acknowledgement is going to be one above that, 485, that is been specified. And finally, there is going to be SYNAC, and then again is going to be 485 is the actual packet, and is going to be acknowledgement for the P816 is going to be changed to 17. And this is what is going to happen with that. So only after the three-way handshake, communication starts. Without this three-way handshake, if you're using TCP, communication is not going to start at all. Right? So one of the reasons why TCP is slow is because of exactly the same reason, right? They'll tell there's one more protocol, right? There's one more protocol at the transport layer called an UDP. It is very much similar to TCP. They'll tell UDP is very fast and TCP is slow. It is not because UDP is sending, let's say TCP is sending at 100 kilometers. The signal UDP is not sending at 200 kilometers. No, both of them are on the speed level are both the same because they're both subjected to the network cable that is there. Depending on the network cable, the speed is going to vary. It has nothing to do with the TCP or UDP. But what happens in UDP is UDP, there is no acknowledgement. Both are exactly the same thing, but there is no acknowledgement in UDP, right? And TCP, for every packet, there is an acknowledgement required. So what is the reason it is slow is that after sending the packet, it is waiting for the acknowledgement and then it sends the second packet. Whereas in UDP, since there's no acknowledgement, it keeps on sending, right? It is just like, you're speaking to someone, you tell them one sentence and then they will tell the other sentence, then you will talk about it, right? It's similar to what you can do in a ChatGPT or anything. When you tell something, Alexa, if you tell something, Alexa will tell, then you repeat the question, then like that, right? But UDP is not like that. You are going to continuously speak and you're not expecting, you don't care, because TCP care whether the packet is received by the destination or not. UDP does not care on that, right? There are multiple places where UDP is used, where TCP is not going to be used, right? UDP is fast, that is very important characteristics. It is going to be used in multiple places, right? That is very critical out here. But we are going to focus more on TCP on it, right? So this is one protocol where that is going to be there, right? So meaning for every service that starts, whenever there is an HTTP protocol, Apache starts, the server will open the port 80 and it will allow packet to listen of them, right? It is going to keep his ears open to check when a packet is open. Remaining all 65,535 ports, in this case, it is going to be -1 in this 1534 is going to be in a closed state. The application will not allow you to run these things out there. Similarly, on the client side, when the browser opens a communication with the server, a random port number is going to be opened out there. Okay. So there is one limitations here. Port number starting from 0 to 2024 cannot be used by client. client cannot use, right? Because it is going to be used for some particular reasons. Even after 1024, I think there are certain reasons up to, I'm not sure about 39,000 something. There's again a registered ports that cannot be used as well for that reasoning out there. Predominantly, the client is going to use ports anything about between 40K to 65,535, right? That is going to be how it's going to be there. Port number, TCP, understanding TCP is very important for you when you're especially working on a network layer devices and things like that. For developing NAT, working on VPN, working on firewalls, all these things will come into that part. If you remember, when we did the firewall out there, we spoke about port number 80 and 22, right? Port number 80 for HTTP and 22 for SSH, because that was working on TCP, right? That was working on TCP. And this, the first 1024 is a pre-configured port numbers for dedicated service. You can't use it. Okay. So that is how it goes out there. And that is how it functions predominantly, right? So this is what a TCP works. There is one more protocol called ICMP. This particular protocol is not used for sending data. Okay. Only used for network troubleshoot. Okay. For instance, let's say for every packet that is sent between this device and the destination machine, there are multiple routers in the middle where it will jump from one router to another router, one router to other router, one router to other router. Only then it is going to reach the final machine out there. You know, for instance, for this example, I can use, right? There's something called as a trace route program. This code trace route 8.8.8.8, right? See, this particular command is going to check what are the number of routers that are there between my device and the destination device. Here I'm using 8.8.8.8. That is a Google DNS server. Predominantly, whenever we want to check whether you are having access to net or not, we are going to do, right, ping 8. Ping 8. 1 second. Okay, it's not visible. Sorry, right? It is there. It is there. So press enter. So it is going to tell. If you are able to ping 8.8.8.8 and get a response back, means you are connected to the internet. That is one way of knowing in the command line interface that you have access to the internet, right? Because if you see here, I can see that I am connected to the internet. In a command prompt, that may not be possible, right? So here you could see there are multiple routers in the middle when it's going from my current Windows system to this particular, right? So here I'm doing this in Windows because Kali Linux certain times the devices in the middle think it is a attack and they will not give out the IP addresses. Okay. So now let's assume. So the reason why I'm talking about this is that you need to know 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 devices in the routers in the middle. Right, from this device to this device. Every time has to pass through this router device, 9 devices only. Okay, there are multiple places. If this router goes down, the packet will not reach the destination. If this goes down, packet will not reach the destination. What if the server is down? How do I know which part of this is having an issue? Right, you need to know, because if something issue with the server, I can call up the other person here, right? I can call the other person here, check, hey, server is down, switch it on. I'm not able to access it. I can do that part. So or if there's some issue with the middle router, probably I've taken another route, saying that, okay, probably that is not best route, do this falling out there. Right? So there's multiple things that could happen out here. And that is what is going to be the ICMP is going to be there, right? For instance, if I give a random, right, if I give trace route, if I give here 10.10.10.10, which this there is no network, right? This network should not be available for me. I'm going to press enter. See, now after it is going to wait for some time, it is going to tell it is not able to reach. So it should not be, sorry, I should not do the trace route. Trace route is not working in my ICMP. It's your ping command that works on the ICMP part. 10.10.10.10. I press enter. Let me increase the font size. It is telling the request timed out. For the first packet, you will try 4 packets out here. Right? And it is telling packets and 4 receive lost and destination is not reachable out there. Right? So this is how it is going to be there. These two technologies are going to be done by our Nmap part out there. Right? If that device is available, if I give ping, right? If the device is available, ping 8.8.8.8, it is going to tell it is reachable and it's telling it took me 11 milliseconds to reach this server. Second packet took 18 milliseconds. Third packet took 11 and fourth packet took 14 milliseconds. That is going to be present on that. Right? So this is the fundamental thing out here. Right? Before I go on to Nmap now, right? We will be going now. This is where it stops from a networking background. Any questions till now for this part? From the TCP part and then ICMP part out here. Any questions from anyone? So is it that went above the concept or you guys understood properly?
Now, I had a quick question. What
Yes.
happens to lost packages?
From a TCP perspective, the lost packets are dropped by the middle devices and the sender will resend that packet to the destination. Right? So because if you see here, what happens when a packet reaches a router? Okay. So some issue is that it will check for that. Instead of passing it forward, it will drop the packet. Meaning it will be temporarily stored in the memory. It will delete that content from the memory is what is going to happen with that part. Right? And here this TTL value that we see, it is also very important. That is also take care of that situation. It is going to delete that packet after certain time out of it. Okay. So if it is TCP, the sender will wait for certain time for acknowledgement. If that acknowledgement is not received in certain time, he will resend the packet. Okay. If the receiver receives 2 packets, that's a packet 5 first, and again after some time it receives packet 5. It will always hold on to the newer packet and delete the older packet. That is also it does.
Okay.
Yeah, that's what it does. Any other questions, guys? Okay. So we'll do one thing. We'll take a couple of minutes break, 2-3 minutes. So after that, we'll start with the scanner part out here, right? So we'll actually scan network when using Kali Linux, and we'll see how to install Nmap in an Ubuntu environment, and how to have Kali Linux. It is pre-installed. We'll talk about that as well. So let's take a 3 minutes break and let's come back after that. In meantime, if you have any questions related to other things apart from topic what we discussed right now, you can ask now as well.
Yeah, I think that will be great. So we can utilize that 3 minutes break. I can see some of our known face, Salesi, Ernest. So, and guys, do you have any question, or should I ask you? Okay, Lode, QLED. So, Ernest, how is your jobs going? So quick question. We just try to switch from our cybersecurity this internship program little bit more hands-on. So what is your thought? Especially Salisi, Ernest, Okil, Okio, because you guys are with us for long time. So it will be a great help from feedback from you guys.
Yeah, I like the both the practical and theory, like mixing the two of them. It's very insightful. I like that.
Great. Guys, do you have any question?
Especially for freshers who are trying to get into cybersecurity, questions related to TCP is very important, right? So you might get cleared, ask questions if you do not understood anything. Probably we can give a little bit of 5 minutes rework on the same thing and come back again, working on the scanners, right?
Yeah.
Because this question will be the first few questions going to be asked, and if you don't answer this question, it is going to be downhill from there because the interviewer will lose confidence in you for knowing the working of TCP for a security professional.
The good part is in the month of November, December, still we are seeing lots of job demand. So what we are thinking for our students and those who have done our job ready trainings and for our consultant, in January it will be tremendous rush because literally last 2 years the job market in US is very low. So we are expecting it is not like any rules is there. So we are expecting a good rush in Jan end or Feb first. So if you have any pending work remain, complete that whatever things you are doing, and if you are trying to move forward in US IT job market, make it sure that your profile is ready by Jan end and by February. Especially those are in GC and Citizen.
Is there a cybersecurity class starting like the morning classes for cybersecurity? Is there any of that starting soon?
Yeah, I think next Friday. And that class will be 6 weeks long. And in Jan, uh, but again, if you are starting from next Friday, make it sure your profile in your LinkedIn profile you are showcasing. Even your class is going, that's fine, but your profile should showcase that you are a cybersecurity expert. So that, and it should be done by December, because while you are changing the and upgrading your profile, LinkedIn or any social or networking profile, it takes some time to settle. Like if you change right now, maybe you will find that thing traction maybe after 2 or 3 weeks, right? And those who have never joined our job ready training, keep eye on the the internship program. Normally, if we find some non-remote like on-site position where which we cannot fill because in that location we don't have any our students who are in our program, or in our without program, like connected with our consulting firm, we place that thing. If you have any the profile is, if it's matching with your profile, feel free to ping me. Now I found there are lots and lots of students from especially in India, they are trying to apply and join the our dedicated group. But please make it understand, uh, if you are in India and you don't have a proper job authorization like H1, OPT, CPT, GCAD, I-140, whatever, if you have no proper job authorization, there is like a 60% chance that most of US position they don't want to sponsor for the visa. If there is a sponsorship available, n- we can also sponsor, that is a different story. But yes, then only it will be much more easier for them to apply, right? Any question, guys, or should we move forward with Karthik? Because here we are actually discussing about three segments. One is technology, like cybersecurity, because Mr. Karthik is the expert on that his field. Mr. Devashish about DevOps, he is expert on his field, and me, we are trying to spread the awareness about the how to get the job and how to create your profile in the US job market. So if you regardless of the internship program, if you have any other doubts about how to approach, feel free to ask.
Okay, probably I think we should restart.
Yeah.
Some.
So Anthony asks, can Internet of Things be explained? IoT, are you asking about?
Yes. It may not be today. Today it's going to
Yeah.
be. Probably we
Now
can look at.
IoT, yeah, IoT is a separate domain itself, but yeah, there is somehow correlated with cybersecurity. About like IoT security is also becoming a very concerning segment in industry,
Yes.
because right, because their company, especially those have a production farm or facilities, and they are right now utilizing many IoT devices. Most of those devices coming from China, and they are not properly secure. And that thing happened quite a bit last 2 years. Many company, because they hacked from their CCTV, their Wi-Fi router, and their one thing happened with their thermostat, that is monitor or manage from a device like mobile device. That IoT actually have a lots and lots of security issue. So I think we
Yes.
can move forward.
Yeah. Probably we can move forward. So
Yeah.
most probably I think one more problem with IoT is that predominantly what we do or in the internship program is directly correlated to what is there in the main course. And in the main course, we are not looking at IoT at the moment. Probably if there is a sufficient number of requests from people who are attending, they want to look at IoT as a security, we can try to add in a session out there for that, not an issue for that. But predominantly, we do stick to what the main course content is, because it also helps people understand what is happening in the course as well. Right. So now let's come back to Nmap. Nmap is a very basic tool and one of the earlier tools that are available out there, right? And it was predominantly used by network admins in the initial stage. You take any pen testing tools or any hacking tools, most of them, the earlier cases mainly were actually developed for administrative purposes. As they see, if you use magic for good thing, it is called white magic, and if you use the same magic for bad things, it is black magic, right? In a similar way, any tool that is used for doing something good is a admin tool. Anything used for doing bad, you can call it as an hackers tool out there. Simple logic out there. So now, what does predominantly an Nmap do? Right? The syntax is very basic. You don't have to go much about it. The basic syntax is you tell the Nmap name and give the IP address or domain name. Right? Give the domain name for that, and that is going to take care of it is going to run the scan. It is going to tell what is the ports that are open available out there. Okay, that is there. Understand one thing. Kali Linux comes with Nmap by default installed. You don't have to worry about that. If you want to install Nmap in your basic machines, all you have to do is sudo apt install Nmap. It will install it for you, right? So now we'll do simple Nmap. Nmap 192.168.178.136, right? This is the IP address of my server, web server, and I'm going to give there and press enter. Right? You see it is gone up pretty fast because both of them are in the same network and it's in VMware environment. The communication of the packets is quite high out there, fast out there. So usually it will take more time. So now you could see here, it is telling starting Nmap scan. It still scan report here, and it is telling out of 983 ports are closed, right? And remaining it is ports it is showing for this. So you might be wondering, Karthik, you told every device has a 65,000 ports, but you're telling it is showing some ports here and about 17 ports it is showing. And what is happening to the remaining 64,000 ports? I will come to that part, right? So here it is very simple. It is telling the port number, what is open, what is the number of the port number, and it is telling what service it is running out there. See here, port number 80, it is telling an HTTP server is running. Port 443, there is an HTTPS server running. FTP 21 is available out there, and different things like port number 3036 for MySQL is running out there. Different services are there. This is what port scanning is basically is about. So what exactly it is happening out here, right? There are multiple things that happens when there's an Nmap scan, when this is given out there. There are a lot more other options we go to look at it right now. This is the basic command that's going to happen out. Okay, so what are the things that is going to happen here? First and foremost, let's look at here, right? It is going to, if a host name is specified, a DNS lookup will be performed and pings the target and host discovery. If an IP address is specified, it does a reverse DNS lookup will be performed and Nmap executes the actual scan. All right. So what is a DNS lookup here? What do you mean by DNS lookup? DNS lookup is very simple. Let's say if I want to know an IP address for a particular domain name, it is going to look for that, right? So because any communication between two devices should be via IP address only, right? But most of the time we will not have the IP address. For instance, google.com, if you could take up here, I don't know the IP address for that. So what can I do? So there is a command like nslookup, which will give me the IP address for that. Okay. For in this case, if I give nslookup google.com, this is going to give me some random IP address that is going to be given to me. So now the nmap first thing is it will do a DNS check, then it will ping 142.250.192.110. Please note here I'm not doing nmap on the google.com. Don't do that. It is not a good thing to do. It is illegal. I'm doing NS lookup, which is a publicly available data from where it is getting. This is totally fine, right? Don't do this in real time. Okay. When you're working inside your company server will be given a domain name that is going to be taken care of that, right? So then it is going to ping this IP. Second one is this. Second point is this, ping this IP address. If the ping reply is fine, then it will continue with the rest of it. Okay. And thirdly, is going to do a reverse lookup, meaning if I get the IP address, it will check whether this IP address belongs to any domain or not. I'm not going to do that particular part here. Okay. That may not be a good idea to go from there. And fourth one is actually the scan that is going to be happen on there. So my question is, right? So if I do like this, right? If I do nmap 136 and things like that, how does the nmap know this particular port number is open or closed? I did the ping. I know whether the device is up or not because I did the ping command, ping the IP, then I'll get a reply. So I can tell the device is up. Since I've got a reply, I know device is up. It is not down. But how does the nmap know this particular port is open or not? So first and foremost, we'll address what is this 983 closed and what is the remaining 1780 showing out there. When I run nmap in the basicest form, right, it is going to scan top 1000 ports, not from 0 to 1000. Okay, most common ports that are going to be there. For instance, here it is checking for 3306, 590, 601, 8080. Those are all ports that are going to be used. They have a list of ports that is there in the top 1000, right? And that is going to be scanned for that. That is why it is now that if I want to scan all 65,000 ports, I have to give nmap -p then give the IP address. Okay, then it will scan all the IP address. If you want to see that, you can just check here. Now, instead of telling, right, 983 ports are open, see now it is taking time. And it was only 1000 ports, it finished very fast. That is going to be the, now we can see here 5516 ports are closed. The remaining ports are open. And now you actually see there are more number of ports here that are open compared to the previous error message of them. But how does nmap know that there's a particular port is open or not? How does it know about that? The process is very simple, right? Once it does the ping command out here and it knows that it is device is up, let's start the port number 80. How does it check whether the port number is 80 is open or not? Right? So what it is going to do, it is going to send a SYNAC packet to port 80, right? In the TCP, you have destination port, right? In the destination port, nmap is going to put 80 and send it out there. If the port 80 is open, what is going to happen? I'm going to get a SYNAC packet back. back. Then I'm going to complete the communication. And if I get a SYNAC packet back, port is open. It is not going to do anything after that. It is not going to send data. It is not going to receive data or anything after that. Once it gets a SYNAC packet back, it knows it is, the port is open, and it does it for all, right? If I do, right, let's say I can do, if I don't specify anything, top 1000 ports. If I specify P-P, all 65,000 ports, that is going to be there. But if I give -P and give port number specific, it is going to work on that particular port only. Like I can give port number 80, sorry, something fine. It is only going to check for that port is up or not. I can give a range also. I can give port number 80 to 90, check which port is in this is open or not. That can also be done out here. Okay. So in this case, it does it for all. But here, what we are going to do is that it is going to check a SYNAC packet, port 80. I'm going to get a SYN and reply back as echo there. Right? But when I send a SYN packet to port number 81, I'm going to get a reset packet telling that whenever I get a reset packet means port is closed. Okay. And that means that is not working in this case. That is what it means. So it does it for all the ports that are there. That is why we have to be very careful. One of the clients, we scanned them and the server crashed because what happened? We scanned 65,000 all ports in that server. And we did it to be sure we did about from 3 machines we scanned at the same time. And it's our 3 Nmaps requested 65,000 packets at the same time. It ended up crashing the server because it was already under load by the normal traffic utilization of that. So then we, customer reached out telling that my society is down. Did you do anything? We told we just did the network scan. They told okay, and they got the server up and running. We did not do the scan. What happened was they told okay, can you wait over till the weekend? In the weekend the traffic is low, then you can do the scan of that and be careful. There are a lot of other things with it to reduce the intensity. I will talk about it now, but this is how it usually goes. It try to establish a communication and see how exactly that is happening or not. Okay, we'll just for an example perspective, we can give it a try. Okay, for instance, let's say for this particular process, I will not use my bbox application here, right? I will use my normal Ubuntu machine. Okay, so I have installed Apache server. In this case, in one place, I will run the Apache and we'll see the port number 80 is open and we see the Wireshark, how it is behaving. And then we'll stop the Apache when that time port is going to be closed and we'll see how it is behaving out there. Okay. Now I know this is a bit technical, but this is what in every scan that is going to happen, that is going to be there. One second, let it open. Yes. Terminal. Let me check whether the Apache is running or not. It should be running. Yes, it is running. So now I will check Nmap only for this particular port, for this particular IP address. Right, IF config. It is 192.129. Right. I'll give Nmap. You want me to increase the font? Okay. -P. Port number 80 is what I'm looking at. I'm going to give 192.168.178.129 is the IP address. Okay, that is what is going to happen out here. And I'm going to press enter. So it is very simple. It is telling the port is open and it is running in HTTP service. Let's try to recapture this particular connection. Right, stop this. See here, there is a SYN and SYNAC packet was received by the target gave back a SYNAC packet. I know that it is a successful one. You might see there is no final ACK packet out here. I'll come to that in a few seconds. Right now, let's look at if the service is not running. Right. So if Apache is not running, what is going to happen? Right. So here Apache is in a disabled mode, so it is not running. The port will be closed as of now. So let me restart the communication. Continue without scanning. Press enter. It's done. Stop this. Right. Since the Apache is not running, the port is closed on the server end. Right. So what is the communication here? You could see the TCP sent a packet, sync packet to the server, and server sent back a reset packet out here, telling that the communication is closed. I'm no longer going to support this communication to work because the port is closed out there. And this process goes on for all the specified port numbers. If I'm giving a single port number, it is going to check only one. If I'm giving 1,000 ports, it is going to scan all those 1,000 ports and it is going to send sync packet to all the 1,000 ports, and it is going to look at the information and reply back. For ports which I'm getting SYNAC, it means the port is open. If the port is coming as reset, it means the port is sorry. If I'm getting SYNAC, it means port is open. If I'm getting reset, it means the port is closed out there, right? There's also one more thing that is going to happen out here, right? What is that? If there is a firewall, right? If you remember, enabling firewall on Ubuntu is very easy, right? First, let me start the service. Right, let me rescan. Make sure port is open. Right, it is open. Now let me start the firewall. Sudo ufw start enable. Right, press enter. If you have attended the previous firewall session, this command it will be making sense for you. So now if I rescan the same thing, it will not show open, it will not show close, it is going to tell something else. It is telling it is filtered, meaning it is not able to determine whether the port is open or closed because nothing happened out there, right? It did not get a SYNAC packet or did not get a reset packet. Something else happened out here for that part. Right? So here, it only sent the sync packet twice. There was no response for that. So now Nmap is thinking the reason I'm not getting a response back, even because it knows with the ICMP ping that one host is up, right? It knows the host is up because I got a reply back for my ping. But this port for this, I'm not getting anything, meaning there could be a firewall. And that is what it is looking at that from that perspective, right? So that is how it checks whether the port is open or closed or filtered. From an hacker perspective, it makes more sense for me only when it is showing as open, right? If it is in a closed state or filter state, it is not going to be of much importance for me because I will not be able to. It prevents or limits your attack process of that. You can't do anything from their perspective. Right. So that is one criteria that is going to be there. So now I can know what is the services port numbers that are open out there. Okay. So point is that one more problem here is that whenever there is a TCP three-way handshake from SYN, SYNAC, and ACK, the machine out here is going to generate a log file telling that, let's say this machine is 10.10.10.10. It will tell that machine 10.10.10.10 established a connection at a timestamp, right? As an hacker, I don't want this to happen. I don't want this to happen. I don't, because if you remember, one of the final phases of pen testing is clearing your tracks. And one of the tracks here is that it has a timestamp. If some attack is hacked, someone goes to this log file, they can see which are all the devices connected to them, and they can also establish this particular attacker machine also connected to that. That will aid in investigation, telling that how that exactly is happening out there. But now let's assume, how does an hacker overcome this situation? How can I do? What is that I can do here to overcome this situation such that the log file is not generated? So it is going to rechange certain thing about the three-way handshake. What it is going to do is that it will not complete three-way handshake. Okay, what does it mean? Let's say port number 80 is open. I send a sync packet to port number 80. And this is going to respond back telling that my port is open. See, this is my sync packet and this is my acknowledgement packet. Instead of sending back an acknowledgement packet like here and completing the three-way handshake, this is going to send a reset packet, telling that I no longer want to communicate. I think I've changed my mind. I will not communicate on that. Because as soon as I receive this particular SYNAC packet, I know that particular port is open. That is the information I need. I don't want any other information. I'll send the reset packet. Since it is not complete, no log is generated. Okay, that is why we saw, when we communicated in the open port, it showed three-way handshake. Let me disable my firewall. UFW disable, because otherwise I will not be able to look at that behavior once again, right? So now let me go back. Yes. Let me continue without saving. Come back, rerun the nmap scan and stop this. We could see here, since SYNAC packet is there, after that there's a reset flag sent by this. This is the default behavior of nmap. Okay. If I want my nmap condition to complete the three-way handshake, you have to write another option out here, right? The main reason is this particular behavior, sending a SYN and SYNAC and then reset. Nowadays, the firewalls and IDPs are configured to check for this exact behavior, right? If someone is trying to establish a connection and closing with a security reset option, it tells, okay, some issue is there, probably I have to think about it. So in those situations, it would be better to go the normal user behavior, probably that way than going in this way. But this is the default behavior, right? It will not do a three-way handshake completely out there. So how does it do? I have to give an option out here. Clear. Same thing. You're running the same thing out here, but I'm going to give small letter s, hyphen small letter s, followed by capital T and press enter. Right. It means please do a TCP handshake, right? It is telling it is open, and you could see SYN, SYNAC and ACK is sent, and after that a reset is sent by it, right? Three-way handshake is completed here. And that is how it is going to take place. Similarly, what we saw here, right? SYN Synac, and reset. This is called as a stealth scan, or it is also called as a SYN scan. Right? How do we force this behavior? If you give -ss, it will make sure it is going to force this behavior of that. Right? That is how it will work. Okay. So same process, you can give -ss, it will run out there. But this is not sufficient for me. This scan type is not sufficient for me. I need more information. Okay. There's something called as banner grabbing. In banner grabbing, I'll get the version information about a service. Okay, I'll get a version information about a service here. So predominantly, if I'm running an Apache, I need the version details.
What do I bring there? Yeah.
Okay, what version it is running out there for SSH also is the same thing. So how do I get this information? Right? How do I get this information? For that, usually when we talk about V option, it means verbose, or here it is also can be taken as version. So it will try to send additional packets to get the version details, right? So what happens is that whenever you're communicating with an application service, it will have something called as a banner. Okay, this banner basically talks about, in certain times, it is for me important to know what version I'm running with, right? Certain times a server needs to know your browser version. That is why every time a browser communicates with the server, it will send its version information to the server, because certain admin protocols will not allow you to communicate using an other protocol, other browser apart from Mozilla or Chrome for that part reason. In those situations, this banner is going to be useful out there. And this will try to, Nmap will try to get that banner information for us. Okay, so now let's use the SV option out there and see, try to get the banner information. First, I'll try to get this, why this banner information is useful for me. I'll discuss about that. Okay, I'm going to run the same thing. Nmap, I'm doing for the bbox machine web server here. Okay, for the banner grabbing for that, and why it is very important. I'll give nmap -p port number 80. I'm looking at TCP scan, right? I'm also looking at verbose version disclosure. Then give 192.168.178.136. You'll see the difference here now. Here we can only see the service name. We want to have the version details as well. So let's look into that. See here, it's taking more time because it's sending out some additional information, things like that, and all those things happen out there. When the version disclosure came in out here, the banner contained a lot of important information for us, right? You can see here, the Apache version is disclosed. It is also telling the destination machine is an Ubuntu machine. It is telling it is using the PHP version 5.2.4.2. Then again, it is telling what version of SSL also it is using. That information is telling out there. Just if I put version for the Apache and PHP, you will see there's a huge list of vulnerabilities that are there that can be used by the hacker to hack into this service out there, right? Why this information is important is that, for instance, let's see, Apache HTTP 2.0. Right. So this is actually right. There is a vulnerability for this, and there could be availability of steps to hack this server, this particular version, right? And this should not be used at all. Okay. And every device will not give out the same amount of information. Certain devices will give less information as well, right? This is giving me a lot of information now. Version, operating system, PHP version. This is very much juicy information for me, right? And since it using a Apache version which is old and which is having vulnerability, it can get hacked as well, right? For instance, if I do the same thing for my other Ubuntu machine, that is my DSO6 Ubuntu machine, you will see it will still give out version details, but it is going to be limited. It is not going to be giving out too much information here, right? So here you could see, here I could get a lot of other information. Here it is just giving Apache HTTP version 4.2.4.52. Just a second, guys. Let me have some water. Right. So for all the services, it can give the same information out here. Just to make it easier, I'm just giving a single port out here. If I run the same thing on the Ubuntu, not Ubuntu machine, on the bbox web server, instead of that port number 80, if I give out for all top 1000 ports, do an SV and SV scan, version scan to give out what version it is running now. This will take some time because it is looking at about 13 different services, and all that services it needs to collect information about that, right? So that is how it is looking at this information. Predominantly securing an infrastructure is not that difficult compared to a web application, right? Web application, we have to go at the code level and look at it and then make modification for that, and it can be a bit time consuming. Infrastructure is quite simple. Make sure that particular port is closed, which is not used. And if you're using a vulnerable version, make sure you're upgrading to the latest version. So if you check out this Ubuntu version for this will be the latest version. So it will not have any vulnerability here. Okay, that's one thing. So like that we'll see. So and make sure the configurations are fine. Your infrastructure is predominantly covered. So let's wait for a few more minutes for this to complete. There's one more option, okay, called as an -O. This is going to give out operating system version details. Okay. And there's something called as -A as well. This will do a lot of things, right? This will do -SV and -O combine and give a few other scans as well. This is called as an active scan. Doing version scans is fine. You have to be very stringent, you have to be very careful about how you're doing. Try to take it slow. Don't do all the services at once. The main reason is the more noise you create, right? More options, more packets you send, more noise you make. More noise means you can get caught, right? So at that time, admin might check out, okay, putting at a particular target, maybe I need to secure that, or I have to block your IP address. That can also be taken into consideration, or they can do that. You don't want to do that. You want to be as invisible as possible. That is why the scanning phase takes a long time. The hackers who hack big banks and big infrastructures, they take a very long time because they are mixing their traffic with the general traffic out there, so that in analytics part it should not come up and it should be difficult for them to track. Okay, that is why I don't prefer using -a option. But if you have spoken to the client and the client is fine and they're fine with the traffic network, high network traffic, then you should go with -a option. It sends out a lot of packet in a very short time. For instance, see, you're getting all the version details here, right? All the different products we had, all the for FTP distiling, for SSH, for SMTP distiling, SMTP, simple mail transfer protocol, postfix SMTP is used, Samba and Apache, all those things are there, right? Do the same thing with -a option instead of this. You'll get the same thing out there. -a, capital, press T. This is very intense. Okay. If you remember before, when we're talking about this, I told there was a situation that the scan was too overwhelming for the server and server crashed. So how do I reduce the speed? There's an option called as an -t option. Okay, this is the timing option. If I give -1, it is very slow. If I give -5, it is very fast. Okay, this has difficult, mainly 5 different speed. By default, it runs at T4. T1 is very slow, T5 is very fast. We have to be careful when we're using it. If you are using in a closed environment, you want to run the scans fast, T5 is good. Otherwise, if the server is sensitive, can't handle the load, T1 would be a good option for that. Okay. For instance, let's see whether -a option is complete. It's still running because this is very large. It does lot more other things. Are there in this. Let's say we'll stop here. For the timing is less. Let me show you Nmap with I will tell for port 1000 1 to 100. Okay, for port 1 to 100, do -TCP connect scan. But I'm telling is what timing should be T5. Make sure it is very fast. So I press enter here. You see it's very fast. It took out less time. So if I give it a T1, you will see it takes some time. It is not fast as before. It is taking you very slowly out there, right? And this is going to make sure it's not putting a load on that, but you have to wait a lot for the scan results to come out and check what is open and what is not open out there. Right. This is not doing anything detailed scan or anything. It is just taking time. The packet sent, the speed it sends is less. That is what is happening out there. Right. So if you want to visually see it, what we can do is let me do speed scan for all ports. And let's capture it in Wireshark, and you'll be able to see in Wireshark. It's not showing. Here, it's going extensively fast out here. It should go much more faster. I don't know why. Let me stop. So it is running in T1. That's the reason. It is going slow because running in T1. Let me go again and start with T5 here. See here, the speed, how it's going fast now. It is going at a very extremely fast rate. And it is covered all the ports is completed out here, right? All the ports is completed, right? So previously it was very slow when it was Stephen out there. So that is the difference, right? So this covers predominantly most of what we use from an Nmap perspective, right? The more than using from a tooling perspective, this topic that we covered today is more predominantly into understanding how a scanner works, because there are Nmap is a very basic scanner, but there are a lot of other scanners out there. And how do they identify services, devices are up or not? All those things are going to be based on what we have done today only, right? So that's it for Nmap. Any questions, guys?
Mr. Karthik.
Yes, please.
Exactly. What exactly is the role of MAP when it comes to the security of our system, in cybersecurity?
Cybersecurity. Uh, from an hacker perspective, right? So if you have seen any Hollywood bank heist movies or anything like that, where they rob a bank, they don't directly go to the bank and start looting it on day one, right? There's a lot of reconnaissance work that happens out there. Uh, that is telling how many people are there in the bank, what is their response time for the police to reach if there's an alarm is triggered, who may be triggering that alarm. All those things are taken care, right? Only based on that, the plan for the attack is going to be designed. Similarly, when you're attacking an infrastructure, I need to know, right, what kind of an operating system they're running, because my payloads are going to change. For Windows, my attack vector is completely different. For Linux, it is completely different. Again, in Linux, if it is in Red Hat based, it is different, and it is a Debian based, it is different. Then again, which servers it is running, right? Typically, most of the time we see Apache is used. There are cases there could be an Nginx being used. In our situation, we saw only one small firewall is there. In reality, there could be a lot of other things, web application firewall, network firewall. We need to map out. We need to understand how to go, what information is there. A map needs to be generated by us to attack the vector of that, right? So those are the things. For that, to collect information about the target, we need Nmap. It is not, Nmap is not used to gain access control or used to maintain your access into that or prolong the attack, nothing like that. Predominantly, only attack I can do from an Nmap is denial of service attack, but it's predominantly 95% of the time used for collecting information about it, right? So that's how it works from an Nmap perspective. As soon as I get a project, first thing I run is the network scanner on the network, right? After that, I go to the attack vectors because I need information. And Nmap is a free tool for doing that exact activity.
So simply, it's like just saying that Nmap is actually used to scan any kind of port vulnerability, right?
Yes.
Okay.
So would it make sense to defend against the information being accessible, like the banners being accessible?
Yes. Yes. So what predominantly what we do out is that if we get a banner information in Nmap scan, we'll take out that banner information and send it to the client. So what I'm going to tell them is that, see, even though the port number 80 is open because you need to open it because your website is depending on that, you still can reduce that information disclosed out there. I don't want Apache to be coming out there. If the banner is fixed, it is not displayed. At that time, I will be in dark. At that time, I might have to try out different attack vectors. A still attack is possible, but now I can tell I can only try Apache related attacks. Now I can't do that. If that information, banner information is not there, I don't know whether they are running Nginx. I have to try Nginx payloads. I have to write Apache payloads. I have to try IIS payloads, Internet Information Server, and different service payloads out there. If there is an IDPS available out there, it will look out for this pattern that someone is trying to send an Nginx for an Apache or Apache related to an Nginx server. Then it will tell attack is imminent. You have to take into consideration someone is trying to gain access for that. So that is there. Right. In some cases, there are cases what has happened is how port is set up, right? Which port they might have been running an FTP server on 21 for transferring that information, and they no longer are using that port service. Okay, but they forgot to close that port. So hacker got into their system, copied all the files because they thought they did not harden the FTP server because they told that is not used. But that port was there and they forgot to do that part. They have not done the audit of it. And they finally they got into that and they got hacked. So then we told them this is what you're supposed to do. And one more thing, if there's a Trojan horse in your server, it will keep an open port, right? Doing a network Nmap scan on your own server on a time-to-time basis, if you see some random port is open, it means your server may have been compromised. Someone has installed a particular Trojan horse for that. And we did that once that was there. And few other times we got the same thing, but at that time they were running a GCP and GCP had installed a dedicated application, some software in their instance, yeah, for managing or monitoring the server. So they told GCP told no, that is not a Trojan. That is our service running on there. We do monitor the instance services out there, right? So that is going to be there for that. Yeah.
So is it same for like the Trojan horse and the rat file?
Yes, it depends, right? What exactly is happening out there? Is your